Today we're going to look at, kind of a wrinkle in the whole idea of algebraic equations compared to what we've seen so far. So far we've seen equations generally, and you probably didn't even really think about this, but they've all had one solution. They've all had only one right answer. Today we're going to say that there's some situations where you might have an equation that doesn't actually have an answer, and sometimes you have equations where there's an infinite number of answers, where absolutely anything will work. So let's look at these situations. So let's just remind ourselves a normal-looking equation like this, right? We got variables on both sides, which is something we've learned to deal with. We have the idea, okay, well, you got to get the x's together. The way you do that is you subtract all the x's from one of the sides. You could either take it from the left or the right. Here we're going to take the 5x away from the left by doing minus 5x, and we do the same thing to both sides to make sure we keep things even. And when we do that, we end up with just minus 6 on the left and x minus 5 on the right. So to get x all alone, all we have to do is add 5 to both sides, and then we're done. X is minus 1. We check and make sure that it works. Plug in the minus 1 by rewriting this equation, and every time you would write x, instead of writing x, you write what you've figured out x is, minus 1. And then you simplify both sides to make sure that they simplify down to what they should. Minus 11 equals minus 11. Good. All right, we've got it figured out. So far, so good. Now, we're going to go back. Remember, this is equation here, 5x minus 6 equals 6x minus 5. We'll tweak it slightly to do a different equation. Here we got 5x minus 6 equals 5x minus 5. All right, so let's get started. We say the priority, get the x's together. Sure, we know how to do that. So I'm going to take 5x away from the left side by doing minus 5x over here. And I'll do the same thing on the right side. Now when hang on a minute. What's going on here? All right, let me, I don't know. Should I add 5 to both sides, I guess? Minus 1 equals 0. What is this? What's going on here? Did I screw up? Did I make a mistake at some point? That's what it'll feel like a little bit when you're getting used to this. But no, you didn't screw up when you're doing the equation here. All that the situation is that you've run into an equation that doesn't actually have a solution. And if we zoom in on what was going on with that equation, right? It started off like this. You may already see what's wrong with this equation, what's making it so that it has no solution. And it's that if you just look at the coefficients here, I know I like you guys to get the x's together first, but let's just see what happens if we just add 6 to both sides here. It would look like this, 5x equals 5x plus 1. And saying something is exactly like itself plus 1 can't make any sense in math. That's like saying 10 is 11, or 15 is 16, or 0 is 1. You can't say that any number is the same as the number right after it. That just doesn't work. So you can't have this thing where you've got the exact same number of x's. You've got the same coefficients for x's on both sides and different constants. Okay? If you have different constants, it's not going to work if you have the same coefficients. Let's look at another example. See, like this one here. This is from page 14 in your unit book, and you do need to complete your entire unit book, so you probably want to follow along with this example now. Fill this in. We know, okay, I'm going to simplify as much as I can first, so I'm going to distribute the 5 here to get 5x minus 20. Now I'm going to try and get all the x's together. Let me subtract all of the x's from the left here, or I could subtract all the x's from the right, whichever one. Let me do minus 5x here. So I do that, and then that leaves on the left, all I've got is minus 20. But when I do 5x minus 5x on the right, all the x's are gone from there as well, and I have just 10. So I've got all the x's gone, no x's left, and I've got two numbers that are not equal to each other, and the equal sign, yeah, these are equal to each other. This equal sign is a dirty lie. This is impossible. It cannot work, right? Let's try adding 20 to both sides, maybe to see if that helps at all. It doesn't. I just end up with 0 equals 30. That's also not true, okay? So if you properly follow the steps for solving an equation, and you end up with a line like that, like we had 0 equals 30, or 10 equals minus 20, whatever it is, if you get something like 5 equals 7, or 1 equals 0, that is, all the variables are gone. All the variables are gone. And you have numbers that don't match, then there is no solution to this equation. And what happens is you write x equals, and then you have a sideways mustache, I know, with a line through it, another sideways mustache. And this is just a notation for saying x has an empty set. There are no solutions. This is how you say x has no solutions. You'll see next year you'll actually learn to write this as a funny looking E, but you'll get used to that next year. For now, we'll just have x equals no solutions. There is some notation for you to understand there. The sideways mustaches, some people call them curly brackets or squiggly brackets. They don't have a great name. This is actually the formal name, curly brackets, but I like sideways mustaches. And then the O with a line through it it's not a zero. It's very different from a zero. Zero is a perfectly good number. This is saying there's nothing there at all. Okay, so when you're writing your answer for no solution, make sure you've got the x equals, then you got the sideways mustaches, and you got the O with a line through it that you write inside the sideways mustaches. Okay, this is what your answer should look like. Now, a good way to understand this whole no solutions thing is to ask yourself, well, how would I write an equation with no solution? And you can actually do this, right? And you say to yourself, okay, I just have to come up with an equation where I've got the same number of x's on both sides and different constants. That's what we had there. Same coefficients on both sides, different constants. So let's say you're saying, well, let me try and write an equation with no solution. Let me start off with, I don't know, minus 3x on both sides. In order to make this have no solution, all I got to do is on one of the two sides, let's make it over on the right here, I'm just going to throw a constant in there, and then this thing can't be true. Let me try plus 19. I've written an equation that has no solution. All I have to do is same coefficients, and then some random number that throws everything off, because these two things are necessarily equal, and this throws that off. Now, you might see situations where you have no solutions, then it's actually disguised. It's not obvious that you've got same coefficients on both sides, but different constants. Like if you look at this here, you might not immediately see that this equation has the same number of x's on both sides, the same coefficients for x on both sides, with different constants. So you have to go on and do the solution here. You have to simplify it. So let me first, I've got here 2 plus 15x. I can't add these together because they're not like terms. So let me distribute this negative into the brackets here. And when I do that, I get minus 2 minus 15x. Now I got like terms here, 12x and minus 15x together. That gives me minus 3x. Now it's more obvious that I've got the same coefficients on both sides, but different constants. So this is going to be a situation where there are no solutions. Minus 3x equals minus 3x minus 2. Now, you also want to be careful because some situations you might think have no solutions. You really need to do the math on them to sort them out. Like you're looking here, you say, like, well, I got 3x over here. I got 3x over there. I know where this is going. This is going to have no solutions. Well, you really have to do the math, get really down to the point where you've got just two numbers that are not equal to each other. So if we do the math here, again, we're going to distribute the negative. We're going to get 20 minus 2 minus 3x because the negative hits each of these guys in turn. So I got 3x equals 20 minus 2 minus 3x. 20 minus 2 together gives me 18. And 3x and minus 3x are not the same. Okay, so it feels like you're dealing with the same coefficients, but you're not. 3 is a very different number from negative 3. That's like saying having $3 million is the same as owing $3 million, and that is definitely not true, right? So let's keep going with the math here. If you had this equation, 3x equals 18 minus 3x, you know you got to get the x's together, so let's try adding 3x to both sides. And when you do that, now I've got 6x equals 18. This is looking much more normal, right? We just got to divide both sides by 6, which leaves us with x equals 3. And if you plug 3 in there, 3 times 3 is 9, 2 plus 9 is 11, 20 minus 11 is 9, and 3 times 3 is 9. X equals 3, plugging in, that actually works there.